Hello and thank you for downloading this OneSteel webinar, which will be presented by OneSteel's Business Development Manager, David Bell. Having graduated with honours in Civil and Structural Engineering from the University of Melbourne, David has been with OneSteel and previously BHP Steel for over 27 years in a variety of design, marketing and development positions. In 2016, David's role broadened to an Australian-wide focus on the steel solutions available for the construction, building and resource markets across the structural steel range of OneSteel sections, including hot-rolled sections and hollow steel sections. David is focused on innovation and market development opportunities associated with steel projects, sustainability, compliance and solutions. The construction industry and regulatory bodies have taken valuable steps to counter the use of non-compliant building products, including by improving the Australian standards regarding structural steel and strengthening the compliance, reporting and traceability measures within those standards. In this webinar, David will explore the wider issues of non-compliant construction products and explain how the various steel standards provide measures that can help you ensure the steel you design, procure and use is compliant.
Hello, and thank you for the opportunity to talk with you all on the topics of steel, compliance and how to get it right. We've been engaged on the topic of compliance for many years, decades in fact. Pleasingly, in recent years, we have seen an awakening of the discussion around compliance and a realisation of the value of engaging more strongly on compliance and not just from the angle of economic rationalism. The building and construction industry now firmly understands that a strong focus on compliance provides enhanced public health and safety, as well as delivering better environmental, social and economic outcomes. So in this webinar, I would like to tell the story around non-compliant products and talk in particular around a few examples that we have seen for structural steel. I will then lead you through how the updated Australian standards are responding to this by providing better means for you to identify compliant products, as well as sharing with you our accreditation to the ACRS third-party product certification scheme. I will finish by discussing the recently released Australian and New Zealand standard that covers the fabrication and erection of structural steel and where you can access more information on the topics I will cover in this webinar. So fundamentally, compliance in the context of this webinar is about ensuring that the steel that you use, procure and fabricate for your projects or structures meets the requirements in the design by the engineer. Issues can arise when the steel design is done to the Australian standards, but the material is manufactured to a standard from a different country, or perhaps not to even any standard at all. The breadth of the suite of Australian standards are all intertwined and interdependent. Holistically, they work together when each part of the chain is followed, when the loadings are to the Australian standard, when the design is to the Australian standard, when the materials and welding done meets their respective Australian standards and so on. When one part of that chain is broken and the loadings, design, materials or welding are not to the Australian standard, the risk of non-compliance increases, even to the point that the intent of the Building Code of Australia may not be met. There is also the increasing understanding that non-compliance of materials can have a detrimental effect on not only the cost, as the structure may have to be repainted, strengthened or even replaced, but it can also affect the safety of those involved in its construction, the users of the structure and the general public. Non-compliance can also affect the sustainability of the project, including from an economic and social viewpoint, as well as the longer-term durability and sustainability of the structure. Other effects can be around brand perception and company reputation. So you can see here that non-compliance could have far-reaching implications, which goes to some of the reasons that compliance is increasing in focus. The challenge of non-conforming products encompasses almost every specified product in the construction market. Over the years, there have been issues with glass, formwork, windows, concrete, electrical cabling, combustible cladding and asbestos found in building materials. There have also been instances of falsification of documentation and fraudulent labelling on building products, falsely claiming their compliance. We have seen very public examples of projects that have used products that did not perform as specified and the effect on both the projects and those associated with them. The takeaway here is that you should not ignore the threat posed by non-compliant products, nor should you assume that it won't affect projects that you are part of. Now, we all know Australia is a fantastic place to live. We also know that Australia is an attractive construction market on the global stage by virtue of the recent mining boom and the ongoing strength in our construction, housing and infrastructure markets. What that means is we are also an attractive market for imported products of all types. The chart you see here shows the massive increase in imported fabricated structural steel over the last 15 years. You can see that the rise is linked in particular to the mining boom and how it has been tailing off over the last 4 years as the construction phase of the mining boom dwindles. However, Australia still sees around 500,000 tonnes of fabricated structural steel being erected every year. This steel doesn't only go into massive resources projects, it can also be quite minor but critical steelwork in buildings and public infrastructure. It's the bridges you drive over, the schools, the shops you walk in, the train stations you stand on, and the schools that your kids and grandkids may go to. And it can come from anywhere and everywhere. A few years ago, there was a government bus depot in Brisbane that used around 300 tonnes of steel. The Department of Transport and Main Road Queensland found that the structural steel came from 19 different countries and 32 different steel makers, all for 300 tonnes of structural steel in a small number of small warehouses and buildings, and not all of that steel was compliant. The challenge for the construction industry is how do we ensure the compliance of this steel, and how do we, as the public who will work in, drive over or walk under these structures, have confidence that they will stand the test of time. Now that's all good and well to talk about the volume of imported fabricated steel as a chart, but how does it translate in a real project, and what are the potential pitfalls for those that have designed and certified this in real life? So I'd just like to show you this example and explain some of the issues that we might all face. What you see here is a handrail system for a walkway. The handrail, instead of being fully welded and galvanised as was designed, was tack welded, had silicone placed over the tack weld to make it look like a full-length weld, and then was spray painted to make it look like it had been galvanised. One can only begin to imagine the ramifications of an injury or fatality that may have resulted from this handrail failing to adequately protect someone at a height. More widely, we've been privy to a number of projects that have had issues with non-compliant products. The first is a road sign situated on a major Sydney roadway. The second is a steel structure that had issues with its galvanising, and the third was a 65-metre long truss that supported an acoustic barrier across a creek. In each and every case, the steel products used were not in accordance with the engineer's specification. In each and every case, the structure did not meet its design intent, its lifespan, or its load-carrying capability. Thankfully, there were no injuries, but the risk of significant injury or worse in all of these situations was a very real possibility. But this is not new. This isn't something that has just started yesterday or last year. This has been happening for a long time. What you see here are the results of a survey done and reported in the Engineering News Record, a preeminent engineering journal from the United States of America, in 2010. They reported on a survey to understand which imported construction products were most likely to be counterfeit. That is, they were not in accordance with the required specification. This included products that were mislabelled, misused, or deliberately substituted with inferior products that did not meet the intended purpose. The study found that steel was the top of the list, with steel-based products occupying the top 4 positions and 6 of the top 10. This speaks in one respect to the substitution that occurs on a global scale of steel-based products, but also speaks to the responsibility of the steel industry itself to provide enhanced levels of identification, traceability and confidence to the designers, purchasers, regulators and users of these products. But it's not all bad news, and indeed the silver lining is that the continued focus on non-compliant products only increases the vigilance around them. The attention of the asset owners is now heightened around the possibility that their supply chain may be compromised by non-compliant products and that their project may be adversely affected. They are taking steps to protect their interests. The design fraternity is increasingly aware of the need to ensure that what they specify on the drawings matches what was actually used in the project else they may become liable for any ramifications of non-compliance. They are taking steps to minimise the risks that they take. The changes in the Australian standards serves to provide increased levels of transparency, traceability and identification of the products and the accompanying documentation that supports and attests to their compliance. And both governments at many levels and the wider construction industry understand that non-compliant products are an issue and are taking steps to address the risks that they raise, and this is a good thing. The Australian Industry Group released a report, A Quest for a Level Playing Field, 4 years ago, and found that non-conforming products impact upon the safety, business sustainability, and can reduce the asset value and increase maintenance costs. The report also highlighted that up to 95% of respondents had seen issues of non-conforming products in their projects. The Australasian Procurement and Construction Council released the second edition of their publication, A Guide to Achieving Compliance, in 2015. This guide provided a list of industry compliance schemes, including the ACRS scheme and also the Steelwork Compliance Scheme, Steelwork Compliance Australia scheme, which I will talk about later. The Federal Senate inquiry on the economic impact of non-conforming products has been reconstituted, prompted in part by the finding of asbestos at Perth's Children's Hospital. The work of the Construction Products Alliance continues to make representation to the Building Ministers Forum and other government forums and inquiries. These outline both the extent of the problem, coupled with recommended solutions and ways forward, especially around risk-critical situations. And industry continues to work with Standards Australia to continually update and refine the suite of Australian and New Zealand standards that provide the compliance measures necessary to ensure the safety and long-term reliability of the structures designed by them. As a steel industry, we have continued to engage with Standards Australia around further strengthening the already strong measures enshrined in Australian standards. In mid-2016, the 4 standards covering the manufacture of structural steels were updated and released, further improving upon the measures introduced in 2009 and 2010. In particular, these standards have new criteria that further provide you with enhanced confidence through better testing, marking, and traceability requirements. There is also a new standard covering the fabrication and erection of structural steel, which I will talk about later. The key aspects of the steel material standards include the requirements for type testing, minimum production testing and inspections by the manufacturers, the requirement for permanent marking on hot-rolled sections and line marking that's applied to all the steels covered by these standards, as well as minimum and mandatory levels of information that are required on the test certificates. And in the coming slides, I will explain these aspects in more detail. In terms of the updated requirements for AS NZS 3679 Part 1, the hot rolled bars and sections standard, which covers the manufacture of hot rolled sections such as those you see here that we make at our mill in Whyalla in South Australia, one major change in the 2016 version of this standard is the requirement for type testing, minimum production testing and inspections that must be done by the manufacturer. These clauses in the standard provide the mandatory and minimum requirements for testing and inspections that need to be done by the steel manufacturer themselves. It also reduces the opportunity for steel to be regraded on the basis of one-off tests. Another advantage of these clauses is that it provides conformance assessment bodies, such as ACRS, with methods to assist them with the certification that they do for steel manufacturers. The second major change is around the requirements for permanent marking on hot-rolled structural steel sections done to this standard 3679 Part 1. But what does this all look like in real life, and how does it help you identify compliant structural steel? So the requirements of the performance-based marking clause in the standard is clearly explained within that standard. It has to be a permanent mark, and it is mandatory on all sections that are at least 150 millimetres deep, and also for all angles where the sum of the two legs is at least 150 millimetres. So this applies to a 75 by 75 equal angle or a 100 by 50 unequal angle, for example. The standard requires that this mark be applied at regular intervals and be no more than 4 metres apart. This marking must also be done at the time of production It cannot be added on after the section is manufactured at the steel mill. So for our ONESTEEL hot rolled sections made to this standard, we put the 1AS mark that you can see on your screen. The 1 signifies that it is a ONESTEEL section, and the AS lettering signifies that it is made to the Australian standard. You should be able to see this easily from several metres away, as the mark must be such that it is visible even after the section has been painted or galvanised. Every manufacturer of hot rolled steel needs to put their particular mark on the steel at the time of manufacture and at regular intervals, regardless of where it is made. This is for every type of hot rolled section covered by 3679 Part 1, be it a beam, column, angle or channel that is at least 150 millimetres deep. So if you're looking at a piece of hot rolled steel in a project that's longer than 4 metres and supposed to be made to AS NZS 3679 Part 1, and you're unable to see a rolled in mark, then it should start to raise concerns about whether that piece of steel has actually been made to the Australian standard. For hollow steel sections manufactured to AS NZS 1163, the cold form hollow section standard, this standard requires line marking that identifies the manufacturer, the mill, where the section was made, and the time and date of manufacture, or another identifier that provides product traceability and quality control measures. In the example you see here on the screen, the line marking can easily identify that this section is from AusTube Mills, which is part of the ONESTEEL business. The AR letters signify that it was made at the Acacia Ridge Mill in Brisbane. The 14321 numbers signifies that it was made on the 321st day of 2014, which for interest's sake was the 17th of November. The timestamps show that these sections rolled off the mill at between 11:32 and 11:37 p.m. Although not required by the standard, the final part of the marking on these AusTube Mill sections identifies that this is C450 plus material, which meets the strength requirements of grade 450 steel in AS NZS 1163, as well as meeting the higher ductility requirements of grade 350 material from that standard. The requirement in the AS NZS 3679 Part 1 standard to have labelling that links the product to the test certificate is also now mandatory for hot rolled sections as well. The information required by the standard includes the manufacturer, the section designation, and an identifier for traceability and process control requirements as the standard to which it is made. So this is how we mark our hot rolled sections that are manufactured at Whyalla. This marking tells you that it was made by ONESTEEL. It's a 14 UB 53.7 universal beam. It came from a certain heat number, the 548049 number, 049 heat, that it has ACRS accreditation, that it is made to the Australian New Zealand standard 3679 Part 1, 350. Just zooming in a little bit closer here, what is useful with these markings is it is now possible to inspect a ONESTEEL section in the fabrication shop and indeed on site, view the matching test certificate and ensure that what was designed is what wound up on site. So the example here shows that you can look at the beam and you can see the heat number on the beam, marry that up to the test certificate, and also view the section designation on the test certificate, and that matches the example I showed you on the previous slide, and also that the test certificate is for grade 350 steel, which matches the 350 mark on the universal beam itself. For reinforcing steels, identification is as easy as locating the individual marks on the steel bars that will tell you not only what the product is, but also where it was manufactured. In the example here, the image on the left comes from the ACRS website, and the photo on the right shows the reinforcing bar in an actual application. And in this case, you're able to match the position of the longitudinal ribs as well as the shape of the transverse rib to show that this steel is indeed grade 500N or normal ductility reinforcing bar from ONESTEEL'S Sydney mill. The bundle stickers that come with the deliveries will also provide that and further information, as well as linking the product to the test certificate itself through the heat number and the corresponding ACRS certificate. Another major change in the steel material standards was around test certificates. Before 2009, there were no requirements for what information has to be put on a test certificate. But now, with both the 2009 and 2010 version, and which has been enhanced and carried through in the 2016 version, there are clear and mandatory requirements for the information that must be provided on the test certificates. The various steel material standards provide a checklist of these requirements, and these are shown on the screen now. This checklist includes things such as the manufacturer's name, the product and product designation, the heat number or the cast that the steel came from, the 14 mandatory elements that must be mentioned on the test certificate, and indeed who has performed that testing and their level of accreditation. We've also put this information on a PDF, which is available from our website, www.onesteel.com, or indeed by clicking on the image of the PDF in the top centre of your page. To provide confidence that the mechanical and chemical testing that is reported on the test certificates is done correctly, there is also now mandatory requirements that the laboratories that provide the testing must be listed on the test certificate as well as their accreditation. This gives you the ability to check that the laboratory doing the testing has both the ability to do that type of testing and also that they carry the correct certification and approvals of the national testing body in their country. In Australia, this is usually provided by NATA, the National Association of Testing Authorities. The transparency that the standard now mandates allows you to go to the NATA website, and if you just look at that number, 07.94, which is the individual NATA number for our lab in Whyalla, it allows you to go to the NATA website and check that the lab mentioned on the test certificate is listed on the NATA website, and indeed that they are accredited to do the testing that they are actually reporting on. In terms of the ACRS scheme, this is a third-party product certification scheme that provides independent certification of a company's ability to consistently manufacture reinforcing, pre-stressing and/or structural steels to the Australian and New Zealand steel material standards. Pleasingly, we are seeing an increased drive by both government and private bodies around both the specification of ACRS at a design stage and also directives to ensure that ACRS certified steels are procured and used in the projects in the construction phase. I wanted to draw out in particular that all of ONESTEEL'S structural steel, hollow sections, reinforcing steels and pre-stressing strands that are made to the respective Australian standards carry ACRS certification, and that more information on this scheme is available from the ACRS website listed. In response to growing evidence of unfair trade practices and inferior imports, the South Australian State Government announced at the Steel Summit in Adelaide, held in February 2016, a more robust procurement policy. In essence, all of their projects require the steel used to be designed to Australian standards, as well as having ACRS certification, and indeed all of the structural steel needs to be fabricated and certified to the new Steelworks Compliance Australia scheme. This heralds a policy that will drive safer, compliant and more environmentally sustainable projects. The Victorian Government is also taking a strong stand in respect of the Level Crossing Removal Authority grade separation works. This is pleasingly also the recent initiative by the New South Wales Government around the adoption of ACRS certified steel in their specifications. More widely, the new Australian and New Zealand Standard 5131 now provides the missing link to the compliance of structural steel. The design aspects are well enshrined in AS 4100. The material requirements are covered through the various material standards I've spoken about earlier in this webinar, and AS/NZS 5131 provides the compliance requirements for the aspects relating to the fabrication and the erection of structural steel, including the fabrication itself, the erection and on-site activities, as well as welding, painting, galvanising and bolting of the fabricated structural steel. There are various tiers relating to the importance of the structure, and this is one factor in determining the various construction categories. If you're looking for further guidance, I would suggest visiting the ASI website for further information. The other part of the equation is in the new standard is the introduction of an organisation called Steelwork Compliance Australia. Their role is to audit and certify steel fabricators to the various fabrication levels that are contained within the national Structural Steelwork Code. In turn, this sets the minimum level of fabricator that can perform the works on the steel structures to the various construction categories. I would also mention that ACRS is used as a compliance criteria for the steel used in the projects. So in conclusion, I would like to leave you with the thought that there are indeed strong compliance measures now enshrined in the various Australian standards that cover the design, manufacture, fabrication and erection of structural steel. The material standards for structural steel were significantly updated in 2009 and 2010. There were further refinements and improvements introduced in the current 2016 versions, all of which provide enhanced levels of information and increase the confidence and traceability of the steels covered by these standards. The recently released standard covering the fabrication and erection of structural steel, AS/NZS 5131, in combination with the National Structural Steelwork Compliance Scheme, provides the strong compliance measures requirements for the fabrication of structural steel. We have been working hard to make it easy for you to understand the requirements of these standards, and especially how to inspect both the products themselves and also how to access and review the accompanying paper trail that exists to help demonstrate their compliance. Thank you.
Thank you, David, and thank you to those of you who have watched the webinar. We hope you've enjoyed it and found the presentation useful. David would be happy to respond to questions about compliance and other specific structural project challenges, and can be reached via the Contact Us section of www.onesteel.com. Thank you very much.